In this video, we're going to look at an example of finding a limit of a function of two variables using the squeeze theorem. So we've given the function xy over the square root of x squared plus y squared. We want to look at the limit as xy as it approaches 0, 0. So in order to be able to use the squeeze theorem, I need to be able to pinch my function that I'm trying to take the limit of in between two simpler functions that I know the limits of. Well, again, it's a lot simpler if I can argue things, if I can combine like terms in the denominator or just get rid of a term in the denominator. So one thing I notice is that my x squared and my y squared are all positive. So if I just drop one of them, say the y squared, my x squared plus y squared has to be greater than or equal to just the x squared. So if I do that, then I know, first off, that if I drop this off, notice I end up with just a y here, right? If I eliminate the y squared, I get square root of x squared, which technically has absolute value of x, right? And then I'm going to be able to cancel those things with either a plus or a minus 1, so I get plus or minus y, if you will. So we can play around with this a little bit. Notice that x over x squared plus y, square root of x squared plus y squared, this is always bigger than or equal to x squared. If I simplify this, my x over absolute value of x is either 1 or negative 1. If I add y squared, the fraction only gets smaller. So this fraction has to be in between negative 1 and 1. We also know that y has to be in between its absolute value and the negative of its absolute value. So that's where we get the next line. If I add a y on top, we get between negative absolute value of y and absolute value of y for the expression. And these are now two simpler limits that we can do. I can calculate the limit as xy approaches 0, 0 of the absolute value of y. It's just 0. We can do that with direct substitution. Since the outer two limits go to 0, the thing in the middle also has to go to 0 by the squeeze theorem.